In this video, I'm going to discuss how the insertion operation can be done at the singly linked list. Insertion of new node can be done in a singly linked list. So when it comes to insertion operation, there are 4 different cases in a singly linked list. The very first one is inserting a new node at the beginning of the list, insertion at the end, which means inserting a new node at the end of the linked list. Insertion, the third case is insertion after a given node, and fourth case is insertion before a given node. So there are 4 different cases under the insertion operation in a singly linked list. Let's discuss one by one. The very first case is insertion at the beginning. Okay, let's take one example. Create one existing linked list now. There is a list with 4 nodes. So this is how the linked list structure will be. First nodes, just imagine that first node's address is PP, second node's address is QQ, third node's address is RR, and fourth node's address is SS, right? And also I just want to store 4 data elements in the linked list. There are 4 nodes here, so I'm going to place 4 data elements in these 4 nodes, 10, 25, 5 and 40. These 4 data elements I'm going to store inside the linked list. So first node holds the data 10, second node holds the data element 25, and third node holds the data element 5, and fourth node has 40, right? So generally the linked list will be like in the linked list, each node's next field usually will be having the address of its next node, right? So the next node of PP is QQ, so it is going to, PP's next field is going to hold the address of the next node, which is QQ, and then again RR here. If so, these 2 nodes will be connected, and then again SS will be placed here. After placing SS here, these 2 nodes will be interconnected, and always last node's next field will be always null. Why? Because there is no further node here to store, right? So the last node's next field will be holding always null. In the previous video I would have already told you like what exactly the node is, how many fields can be there in each node, everything. So always when you take a node, by default there should be a data field as well as the link field should be there, right? So in data field will have the actual information of our data, and the link field will be having the address of its next node, right? So now QQ is stored here in the previous node, RR will be stored in the previous node again under the address QQ, and SS is stored over here. So where now the first node's address will be stored, because like for further nodes there is a previous node there, so like the address can be placed in the previous node's next field. When it comes to the first node, there is no previous node, right? So to store the address of the first node, we have to initialize the start variable with the start address of the linked list. So there is a start variable. Under the start variable, we are going to store the address of the first node. Address of the first node is PP. Since there is no previous node for the first node, we are storing the address of the first node under the start variable. So we are initializing the start variable with the address of the first node, right? So now this is the complete linked list structure. Now we are going to write the pseudocode for performing the insertion operation at the beginning. For example, number 20 at the beginning I want to insert. So this is the existing list, right? The existing list is given here. Now I want to insert a new node which holds the data, the new value 20, and I want to place that node at the beginning. So the very first step is we are supposed to create a new node, because when it comes to linked list data structure, it has the collection of nodes, right, with the data field and link field. So the very first step is creating a new node. I am creating a new node here. Okay, new node is created with the 2 fields. One is data field to store the actual data, and the next field which will hold the address of its next node. So new node is created. Imagine that the address is also new node, whatever, some address will be there, so new node is created, right? So after creating the new node, the very first step is, in the place of the data field in the new node, I can place the number which I want to insert, 20. So the very first step is, in the place of where the number, the value which you want to insert can be placed at the data field in the new node, right? So in the place of new node's data field, I'm going to place the number, the new value which I want to insert, right? So after writing this line, in the place of new node's data field, number will go, which is 20. And the next step is, because I just want to place the new node at the beginning, right? The next step is, so after creating the new node, I place the value 20. Now this node is supposed to act as the very first node after inserting it, right? So before you place it at the beginning, you have to check like which is going to be the next node of this new node. So if I place over here, the next node is going to be the current first node in the list is going to act as the second node for this after inserting this new node, right? So I'm just in the place of new node, next field, which is supposed to come, because this is going to act as the new node, right? So these two should be connected. When these two will be connected, when you place the address of this very first node at the next field of new node, these two will be connected. So where is the address of this first node? It has been placed under the start variable, right, which is pp, right? So in the place of new nodes next, you are going to write start. What is there under start? The address pp is there, right? After this line, in the place of new nodes next field, the address which has been stored at the start will come over here. So after writing pp over here, the new node as well as the node which has been placed under the address pp will get interconnected. Now the next step is, so now this node is acting as the very first node. After this node, your previous first node is acting as a second node of it. Why? Because we have inserted the new node over here. So this is the first node and second node, and all other and further nodes are over here. Now this is the first node. So always first node's address we are supposed to store under the start variable, right? So the next step should be, we are going to write the address of the new node under the start variable. So what should be now? Now the address pp has been placed under the start variable as well as under the new node. So now we are just going to replace this with new node. So you can write start equals to new node. When you write start equals to new node, under the start, automatically the new node's address will come. Now this connection will be disconnected, and after writing new node's address under the start, these two will be connected. Now the complete list is ready with the new node. We have inserted the new node at the beginning. We have replaced the addresses now. Now we got the flow here. So new node is going to be the first node, pp is the second node, qq is going to be the third node, rr is the fourth node, and ss is the fifth node. That's it. Insertion at the beginning is over. And next, the second case is performing insertion at the end, which means inserting a new node at the end of a linked list. Again, we'll take one example. The same list we will take now, 10 with 4 nodes. Imagine a list with 4 nodes. And one start variable to store the address of the first node. So QQ will come here, RR will be here, SS and last node's next field will be null, and data values are 10, 25, 5 and 40. Now number 20 I want to insert at the end of the list, the current list, right? Now, so end of the linked list means our new node should come here. Very first step is creating a new node with the data field as well as its link field. So new node creation is over. Number 20 I just want to insert in the place of new node's data field. So very first step is in the place of new node data field I can place the new number which I want to insert. Okay, new number is inserted here. Next step is, since we are performing the insertion at the end, we all know that always the next field of the last node will be having the null value. So in the place of new node's next field, directly we can write null. Fine. So new node is created, data field is also filled, and the next field is also filled. The next step is we have to connect these two nodes so that the new node can act as the last node, because we are inserting a new node at the end. Once this node is inserted, the new node should act as the last node in the linked list, right? So if you want to connect these two, you need to find this node first, you need to find the last node first, right? So directly we cannot find the last node here in the linked list. Unlike an array, a linked list does not allow random access of data. So elements in a linked list can be accessed only in a sequential manner. If so, we are supposed to start from the beginning and you need to find the last data. How will you find that? Like, what is the identification? Like, how will you find the last node? Means like the node which has the null value in its next field, we can call that node as the last node, right? So until we encounter the null value at the next field of any node, we are supposed to keep on traversing it. Once we reach the null value, we have to stop and we can start connecting the last node with the new node. So we are going to use a loop here. So use while loop, right? We are going to start from the beginning. So before you use a loop, you are supposed to initialize a pointer. The very first step should be, we are going to use one point. We are going to use one pointer. We are going to initialize the pointer with start address. So what is there at start? Under the start, the address pp is there. So at the very first step, the pointer will be pointing the address pp. Why? Because under the start pp address is there, so it will be pointing the node pp, right? Pointer is pointing the start node. Now you use a loop. Until when we are supposed to traverse the pointer? Until we reach the null value at the next field, we are supposed to traverse the pointer. We have to keep incrementing the pointer node by node. So use a loop. The condition should be while pointers next field is not equal to null, you can keep on incrementing the pointer. So right now the pointer is pointing the start variable which is pp. Check pointers next field. Pointers next field is not null, right? If so, you are supposed to increment the pointer. How will you increment the pointer? The statement should be pointer equal to pointer next. So now the pointer is pointing the node pp. Check pointer next, that is qq. So I am incrementing the pointer to which position? Pointer's next position. Pointer next is qq. So now my pointer will be pointing the node qq. Then again check whether the pointer's next is not equal to null. Yes, it is not equal to null. If so, I am supposed to again increment the pointer. Pointer equal to pointer's next. Pointer's next is rr. So my pointer will go to the node rr. Check pointers next again. Pointers next is not equal to null again. So I am supposed to increment the pointer. Pointer equal to pointers next. And the place of pointers next ss is there. So now pointer will be pointing the node ss. Now again check the condition. Pointers next is not equal to null. No, pointers next is equal to null here. So when pointers next is equal to null, it will come out of the loop, end of loop, and the next step is we have identified the last node now. So only one step is remaining here. Just in the place of, because now the pointer is pointing SS, so in the place of pointers next field, if you write the address of new node, so in the place of pointers next field, instead of, you just remove this null value and write the address of new node, right? So after SS it is supposed to point the new node, right? So now after this statement these two will be connected, because we have written in the place of pointers next field the new node's address has been written here, so these two nodes will be connected. Exit. That's it. So this is the pseudocode for performing insertion operation at the end of a linked list. Thank you.